Hello. In this video, we're going to take a look at a for loop. Now, there are two classifications of loops. Uh, Condition controlled just use a very simple Boolean expression that as long as that expression continues to evaluate to true, the body of the loop will execute repeatedly. In a for loop, we have something known as a count controlled loop. A counter controlled loop has a integrated counter as part of its statement that will basically use a counter variable. A count controlled loop has kind of three parts: an initialization, uh, a loop continuation expression, and a modifier. How are we going to change what we know as the counter variable after each iteration of our loop? Iteration just being a fancy word for lap. So I'm going to go ahead and run pretty much the simplest for loop I can write. And then we'll talk about its behavior. Actually, what I like to do here is let's use a very small loop. I'm going to change that to a 3 so we can trace it more easily. So I have my keyword for, and then the parts needed to set up the for loop, and then the braces, which create a block, which is going to be one or more statements that I want to run repeatedly. So the first time the for loop statement is encountered, we're going to run the initialization. The initialization is only going to run the first time. So I declare a variable. You should not use doubles or floats. You should typically stick to integers. And it's kind of tradition that for loops can use any counter variable name you like. You could use counter. If I'm simulating something like days of the week, you could say day. But I is probably the most used variable ever because it is kind of tradition to use I as the counter. Okay, I'm going to start that value start I at my desired value. I'm going to look at my loop continuation expression. So the first time this runs, I was set to 1. 1 is indeed less than or equal to 3. And so we're going to do the statements in the body of the loop. And so that's where I would do my printout, I is currently 1. When I get to the bottom of the loop, then I'm going to do my counter modification, which in this case is the post increment operator, meaning when the current structure is finished, statement, or we can't say line when we talk about a for loop. It's basically when the current iteration is done, we're going to add 1 to I. Then we're going to come back up and see if the expression is still true. Well, I was 1. When we added 1 to it, I became 2. Come back up, test our continuation expression. 2 is less than or equal to 3, so we're going to run another iteration. So we'll run the statements in the body of the loop. We would print out I is currently 2. We get to the bottom of the loop. We run our counter modification. So 2 plus 1 would be 3. Come back up, test the expression again. 3 is indeed less than or equal to 3. So we're going to run another iteration. And we'll spit out I is currently 3. We get to the bottom of the loop. We're going to run our counter modification instruction. So 3 plus 1 is 4. We'll come back up. Our continuation expression is now false because 4 is not less than or equal to 3. So I exit the loop, stop running statements repeatedly, and I'll resume running additional statements below the body of the loop. Okay, so I'd like to take this opportunity to just show you a couple of weird variations, things we could do with this. So first of all, it is possible to write a for loop that never executes. My IDE here, IntelliJ, is actually smart enough to know that, hey, you've written a loop that can never run. Because in this case, if I initialize I to 11, 11 will never be less than or equal to 3. And so we're not going to run any iterations. Okay, we didn't print out I is currently at all. It is possible to write a loop that counts backwards. We might say I equals 10, while I is, let's say, greater than or equal to 0. And maybe we'd want to subtract 1 from I each time. And we can see my loop counted down backwards. Let's change this to be back then I is less than 10 again. Okay. You'll want to be careful about how you write your expressions. You can use less than or equal to, equal or less than, greater than or equal to, or greater than. How you write that will dictate how many iterations we run. So in this case, let's say I'm absent-mindedly writing this program and I'm expecting to see 10 iterations. Whoops. Oh dear. And I've just written an infinite loop. We're going to go ahead and stop that. Okay. An infinite loop, if you haven't seen an earlier demonstration of it, is when I have a loop that never finishes running. Because I got ahead of myself. I forgot that I was changing this from counting backwards to forwards. And so while I less than 10, that never evaluated to false. And so my computer just started running codes. My computer just ran what? 1,733,000-ish versions of this statement. In the bad old days, an infinite loop would actually crash a computer. Modern operating systems are now better able to handle this kind of situation, but infinite loops are very bad. Okay, so let's run this again and make sure we're back where we want to be. There we go. That's behaving better. And so the talking point I was originally going for is, depending on how you write this, I've run 10 iterations, but I started my counter at 0 this time. And it's very common to start counters at 0 instead of 1. And that is simply because later on, you're going to encounter list-like structures, such as arrays. In a list-like structure, it is very common for the internal numbering of many programming languages to number the first item on the list with 0 instead of 1. As a matter of fact, forgetting about that, if I forget about that and I'm working with one of those lists, but I start my counter variable at 1, you end up with what we call an off by 1 error, where, if I had entered grades of 100, 180, I would lose that first 100, and so the average would go down. Okay, so in this case, let's pretend I'm still hoping for 10 iterations, but in this case, I did not write my continuation expression correctly. So I've actually only run 9 iterations. So paying attention to your ranges, paying attention to how you write that expression is pretty important. It's worth pointing out that we could do a more complicated expression here. Okay. And now I've got something that is basically counting off by 2s. Let's see. I think I've demonstrated in this video that a for loop categorized or classified in 2 different ways. First, it is a count control loop as opposed to the condition control loop of while and do while. It is also a pretest loop in that it is possible to write this in a way that never runs any iterations. And then finally for this video, I think I've got some pre-typed code sitting off here in a notepad file on the side. It's possible and quite common to use user input as one of the variables involved in my continuation expression. Okay, so I'm going to let the user enter in. The user is going to enter in how many iterations they want, and I'll use that as part of my continuation expression. Let's go ahead and run this. I want 100 iterations. Okay. So a for loop is useful for when you or the programmer have some way of knowing how many iterations you're going to need to run. For example, if I'm simulating days of the week, I might go from 1 to 7 or 0 to 6. If I'm doing months of the year, 1 to 12 or 0 to 11. Or I might ask the user, how many grades do you have to average? A while or do while loop is more appropriate when you don't know how many iterations you have to run. As a matter of fact, that might be the purpose of those programs. If my credit card balance is this much and my interest rate is this much, how many payment periods, monthly payments, will I need to pay this off as you add in the interest and subtract the payment? A for loop is a better choice for when you know how many iterations you want to run. I'll also point out it is legal but not advisable to change the value of the counter inside the body of the loop. Depending on what order you're watching these, when I'm doing a while or do while, you pretty much have to change something involved in the while expression, the continuation expression, for this loop to eventually evaluate the false. If I don't do that, I end up with an infinite loop in my while loop. Okay, so again, this is bad. Let's see, 10, and you see my computer is just freaking out. Okay, so in a while loop, you want to modify something involved in the continuation expression inside the body of the loop. With a for loop, that is legal, but it is inadvisable. The whole point of a for loop is you've got the three parts you need to control exactly how many iterations you're going to run. Okay, so if I do my for loop with this variation, okay, I want 10 iterations. But you can see because I modified that value, let's pull this up a little bit. 1, 2, 3, 4, 5. I only ran 6 iterations. So this is generally inadvisable. Okay, I hope this video was helpful.